Alright, next lecture we're looking at tangents and normals. So, tangents and normals are both straight lines. So we looked at tangents and normals before. We looked at them when we did lines, when we did circles. So now we're going to try and find them for any function. So just quick recap. Tangents have the same gradient So tangents have the same gradient as the function or the curve. So we did that when we had circles. If you had a circle, it would have had the same gradient as the curve, so it would have been perpendicular to the radius, which was like the normal. But yeah, tangent will always have the same gradient as the curve. So if I drew a quick sketch of x squared, the tangent would be, if it's put tangent there, at that point the tangent and the curve have the same gradient. Normals are perpendicular to the curve, so if you had x squared again, this could be our normal to it, and it'd be at right angles. So the normal gradients have to be minus 1 over m to the curve. So for example, we'll try an easy one first. Find the tangent of y equals x squared plus 5x minus 3 at the point where x equals 1. So find tangent of this when x equals 1. So first thing, let's find the gradient. So we're going to differentiate this. So dy by dx is 2x plus 5. Now, we haven't done this yet, but if you want to differentiate 5x, if you imagine that's x to the power 1, 1 times 5 gives us 5. Take 1 from the power of x, so it'll become x to the 0. And remember, anything to the power 0 is 1, so we just get 2x plus 5. So x terms just differentiate to give you the number. What about this number term though? So minus 3, there aren't any x's in it, so we have to imagine that minus 3 is like minus 3x to the power 0, because x to the 0 is 1, so it would be minus 3 still. And if you differentiated something to the power 0, it would just disappear. So when you differentiate a number on its own, it just disappears, it's gone. So we just kind of drop a degree. So here we had y equals x squared, x and no x's. Here we end up with x and no x's straight away. So the last term in this case just disappears. Now we want the gradient when x is 1, so let's put in x is 1, and we're going to get 2 lots of 1 plus 5, which will give us 7. So our gradient for this tangent is 7. Now you need two things when you find the equation of a line. Remember, you need a point and you need a gradient, but at the moment we don't have a y value. So if I substitute x is 1 back into our original y equals function, we're going to get 1 squared plus 5 times 1 minus 3, so 1 plus 5 is 6, take 3, so our y value is going to be 3, so y equals 3. So to find my equation of the tangent, it's going to have the same gradient, like I said up here. Tangents have the same gradient as the functional curve. So we're going to get y minus 3 equals 7x minus 1. So y minus 3, 7x minus 7, so y equals 7x minus 4. So that is the tangent to this curve, this quadratic, at this point. So if I drew that quadratic, move down here, there's going to be a tangent when x is minus 1, and it's 7x minus 4. It should be something like that. Cool, right, next bit, we're going to try and find the normal to the same curve. So this is going to be the line at right angles to our curve. So same idea again, we still know y equals 3, we know that x is 1. So we could put in the same point, you get the same gradient again, the gradient would still be m equals 7. So our perpendicular gradient, because we're talking about a normal now, is going to be minus 1 over 7. This is going to turn out horrible. So y minus 3 equals minus the 7th, x take 1. let's times up by 7 to make it easier. 7y minus 21 equals minus x plus 1. Add 21 to both sides, so 7y is minus x plus 22. Let's get it all on one side. 7y plus x minus 22 equals 0. So that would be our normal. Alright, let's try a couple more examples of this. So we want to try and find, that can't be right, can it? Yeah. We want to try and find the normal to this curve at this point. So we're going to find the gradient. So 15x squared minus 7x. At the point where x is 1, so dy by dx, x equals 1, gives us 15 minus 7, which is going to be 8. So our gradient, because it's the normal, our gradient is going to be minus 1 over 8. So let the examiner know that you know the difference between tangent and a normal, and that you know the normal gradient is perpendicular to the tangent gradient. And then we can use our point. So y minus 1 equals minus an eighth. X takes 0, so we get y equals minus x over 8 plus 1. Cool. Right, what have we got next? Alright, one more question, then we're done for this this lecture. So we're going to try and find a tangent and a normal this time. So find tangent and normal to this curve at that point there. So difficult example. We've got a root sign here on the bottom, so we have to sort that out first. So my first step this time is going to be rewrite y in a form we can differentiate. So I need to rewrite this in a way that we can differentiate it. So x squared there wasn't a problem with, that's fine. This we need to sort out. So I'm going to bring this up using negative powers and sort out this root sign using fractional powers. So I'm going to get minus 8x to the power minus a half. So root, remember, is a half. X on the bottom, if you want to bring it up to the top, we can call it minus. The 8 stays where it is. So that's my y equation. So if I want to differentiate it now, I can. So step 2 is differentiate. So I'm going to get dy by dx is 2x to the power 1. Now we've got to do minus a half times minus 8, which is a bit of a pain. So 8 times a half is 4, and then minus times a minus is a positive, so we get plus 4. And then we've got to take 1 from this thing. So we're going to get x to the power. Minus a half, take 1. If you think that through, it's going to be 1 take away, or minus a half, and then minus another 1. It's going to be minus 1.5, which in other words is minus 3 over 2. So there we go. That is our gradient function. And now we want to try and find what the gradient is at this point so that we can find the normal. So we're going to put in the point 412, so put x equals 4 in here. So we're going to get 2 lots of 4 plus 4 times 4 to the power minus 3 over 2. I actually do this in my head. So 2 times 4 is 8. 4 to minus 3 over 2, well, let's root it first, and we're going to get 2. 2 cubed, it's going to be 8. So minus, so it's going to be 1 over 8, so plus 4 times 1 over 8. And I can work this out, it's going to be 8 plus 4 over 8, which is 8.5. Or in other words, it's going to be 17 over 2. So that's our gradient. So our normal gradient is going to be the negative reciprocal of that. So normal is going to be minus 2 over 17. Lovely gradient there. And then to work out what our equation this line is, so our point, remember, was 412. So if we do y minus 12 equals minus 2 over 17, x take 4. And if we expand all that out, y minus 12 equals minus 2 over 17, x plus 4 over, that's right, 8 over 17 that should be. And then we can solve this. Where's my calculator gone? So we're going to get y equals minus 2 over 17 x plus 212 over 17. Cool. We can do the same thing to find the tangent as well. So tangent is going to have the correct gradient over there. So m is 17 over 2. And we got 412 at that point. So y minus 12 equals 17 over 2. X take 4, which if you work out is going to give us minus 34. Add 12, so we get y equals 17 over 2x minus 2. So there's our tangent because we use the same gradient. And there's our normal because we use the negative reciprocal gradient. Cool. Right, that's it for this video. So on to the quiz for this one, and then one more for this week.